Oxidation reduction reactions is our last type of chemical reactions that we're talking about. So we are going to examine and investigate these kind of reactions in this video. So what are oxidation reduction? They're also called a redox reaction. And what are they called that? So redox is reduction and oxidation. So they call it redox reaction as a short form. But whatever you call them, they are the reaction that you have electron transfer in them. So in other type of reaction that we talked about in the previous videos, we have precipitation reaction that ions swap partners and form a solid precipitate. We had acid-base reaction that again we had a swap in the partners, but we formed salt and water. In these kind of reactions, we have a transfer of electron. So what do we mean by that? So let's look at our first example. So when you mix solid sodium with chlorine gas, you see that there is an electron transfer and you form salt, NaCl solid. So unlike the previous reactions that we were studying, it was all in aqueous. Redox reaction could be in aqueous or could be in different phases. So it's not just in the aqueous solutions. So this first example shows a solid with a gas. So if you have a container that you can cut piece of sodium metal, which is very soft. So if you cut it and put it in the container and then you add chlorine gas into it, you'll see it will ignite. You will see it flame and it forms the crystalline salt of NaCl in your container. So what happens in that reaction? So if you look at sodium in here, you see sodium, it's sodium salt, it doesn't have any charge, so the charge is 0. But in the product, it's sodium chloride. So you know it's an ionic compound. It is sodium plus and chlorine minus, right? So you have a change in the charge. So if you look closely at just look at the sodium, this reaction, you have sodium, and in the product you form sodium plus with electron. Okay, so you are making some electron by making sodium plus ion. Okay, one thing to remember that where you should write the electron is that both sides of the reaction should have the same charge. So on the left where the reactants are, you see the charge is 0. So on the right, on the product side, also the charge should be 0. So you have a plus charge here, so we should have a negative charge also. So electron has negative charge, so you have 2 sodium and 2 electron to makes it balance, sort of. So it's a balance of charge. So because in the reactants we have 0, it should be 0 on the product too. You see we have all of these 2's, and you know if it's a chemical reaction, it should be just 1 sodium makes sodium plus and 1 electron. But since this is the half reaction, we're going to talk more about it in the next slide, it should be 2 because we have to make 2 electron because the other reaction also needs 2 electron. Okay, we talk about this more on the next slide. So if you look at the chlorine, what do we have in the chlorine? So in the sodium we have sodium 0 to sodium plus. In chlorine we have chlorine is Cl2, so this is also have the charge of 0. So chlorine 0 become chlorine anion, it's chloride, it become chloride basically. So what happens in chlorine? We have Cl2, it takes the 2 electron which is transferred from the sodium and it becomes Cl minus. Okay, because Cl gas, chlorine gas, is a diatomic gas, it's Cl2, so it needs 2 electron to form 2 Cl minus. Okay, so now you see it's balanced, and that's why it needs 2 electron, because the neutral chlorine is Cl2, it's a diatomic, so it has two chlorines. In the product, chlorine as an ion, so when you have Cl2, you make 2 Cl minus. And since it needs to be charge balanced, you see in the reactant side of the reaction, the charge is 2 minus. So on the product side, it needs to be 2 minus 2. So we have each chlorine is 1 negative charge. So we have 2 of that. So in total, you have 2 negative charge. Okay, it's charge balanced on both sides of the reaction. So as I said in the previous slides, these are called half reactions. Okay, so in this redox reaction, there are two half reactions. So in a half reaction, you have oxidation reaction and you have reduction reaction. That's why it is called oxidation reduction reaction or redox reaction. Okay, the oxidation reaction is the sodium, because we have a loss of electron. That's called oxidation reaction. Loss of electron is oxidation reaction. So that's in sodium, we have loss of electrons. So in the product, you have sodium cation and losing 2 electrons. Okay, so that's oxidation reaction. With the same logic, in chlorine, we have reduction reaction. Chlorine is gaining electrons, so gaining electron is reduction. So chlorine gained 2 electron and formed 2 Cl minus. Okay, so these two half reactions are forming the full redox reaction. Each one of these reactions cannot happen by itself. So if a reduction reaction is happening, there should be an oxidation reaction to have this electron transfer. Okay, because if this happens and you make these 2 electrons, it's not like these electrons are going to just sit there and look at these ions, right? It should be transferred into something else. So the chlorine is going to take those 2 electrons and form Cl minus. So then we have sodium plus and Cl minus, so that forms NaCl, the salt. So that was one way to remember it, and it's easier for me because you look at the oxidation state or the charge. We're going to talk more about oxidation state in the next video, but let's say that's just the charge. So when you have a reduction in the charge, for example, you're going from 0 to -1. So you have a reduction, you're going down. Okay, so you have a reduction in the charge, so that's a reduction reaction. Okay, if it's opposite, the opposite is oxidation. Okay, so if you have increase in the charge, you have oxidation. Okay, so increase goes with oxidation. Reduction or reducing, oh, it's just the same word. So reduction in the charge is a reduction reaction. Okay, that's one way to remember it, and that's easier for me. It might be easier for you, but there are some other ways. I just tell you, whichever feels fine for you, go with that. Okay, so the other way is Leo says Ger. Leo is the lion, and that's, you can use that. So Leo is losing electron. I don't write the rest of it. Losing electron is oxidation, and Ger is gaining electron. Electron is reduction. Okay, so losing electron is oxidation, gaining electron is reduction. That's one way to remember it. You might have heard about oil rig. So oxidation is losing electron and reduction is gaining electron. Whichever works for you, go with that. I prefer reduction in the charge is reduction, and the other way is oxidation. Okay, that's easier for me. So there are some other terms that we have to know about in the redox reactions, which is oxidizing agent and reducing agent. So oxidizing agent is not the one which is oxidized. Oxidizing agent is the agent that makes other things to be oxidized. Okay, so in that case, that substance needs to be reduced to make something else oxidized. Okay, so if something is oxidized, it's reducing something else. So if you think about it, it's electron transfer reaction, right? So if something is oxidized, it has an increase in the charge, so it's losing the electron. So if something is oxidized, it's giving these electrons to something else, so it's reducing something else. Okay, so if anything is oxidized, it's reducing agent. If something is reduced, is oxidizing agent because it's oxidizing something else, so it's oxidizing agent. Okay, that might be a little bit confusing, but if you think about it as an agent, agent is doing something, is doing that title. Like actors have agent, they don't do the acting, they just find the job for the actor. Just an example. So oxidizing agent, when you say agent, agent is the thing that do something for some other people or other substances. Okay, so oxidizing agent is something that oxidize other substances. In order to oxidize something else, it needs to be reduced. Okay, so oxidizing agent is a substance that is being reduced, and reducing agent is substance that is being oxidized. Okay, so let's look at some of these examples. So the first one is our first example. So sodium is in solid state, should be in solid, and this is in gas, and sodium chloride is in solid state. So from 0, it goes to +1. You know, when you say NaCl, you learn about ionic compound, okay, right? So you know there is a cation and there is an anion. So when you have cation and anion, you know the sodium is a cation, it has a plus charge, and chlorine is an anion, it has a negative charge. So when you see there is a change in the charge, it's a redox reaction. Also chlorine, Cl2, it doesn't have any charge, it's 0. But in the product as NaCl, it's Cl minus, so it has a negative charge. So it's going from 0 to -1, so it has a change in the oxidation state that we are going to talk about, or let's say just charge. There's a change in the charge, so it's a redox reaction. So sodium has increase in the charge, so it's oxidation. Chlorine has reduction in the charge, it has a decrease in the charge, it goes from 0 to -1, so it's reduction. Okay, let's see our next example. You have zinc solid and copper nitrate, right? So you know about polyatomic ions, it's nitrate has -1 charge and you have 2 of that, so copper should be +2, and zinc is in the solid state, so it's 0. In the product, zinc made an ionic compound with nitrate, so we have nitrate, again the same charge, so nothing changed in the nitrate is fixed, but zinc is now +2, right? Because you have 2 nitrate, it's +2. Copper is in the solid state, so it has a charge of 0. So zinc is going from 0 to +2, so it has increase in the charge. So when you have increase, it's oxidation. Copper, on the other hand, going from 2 plus to 0, so it has a reduction in the charge. It's going from 2 plus to 0. It's going down. So when it's going down, it's a reduction. It's a reduction reaction. Okay. So that's a redox reaction. When you see there's a change in the charge, that's a redox reaction. Okay, the last example, we have calcium as solid, so it's 0. And in product, it's calcium hydroxide. Hydroxide is a polyatomic ion. You know the charge is -1. You should know, I mean, you have to memorize these. And you have 2 of that, so it's 2 negatives, so calcium should be 2 plus, right? So from 0, this goes to +2, so it's an increase in the charge, so it's oxidation. For the other one, these half reactions cannot happen without the other one. So if you have an oxidation, there should be a reduction too, but it's a little bit hard to see it because H2O is a molecule, doesn't have a charge. But each of these elements have an oxidation state that we talk more about this in the next video. But there should be a reduction in here. There should be a reduction in hydrogen that to make this whole reaction as a redox reaction. But we don't know it yet. We learn it in the next video. Something that you have to know that I talked about this in the first video, that the number of electrons gained or lost must match. Like our first example, when you write a half reaction, sodium makes sodium plus an electron, right? And chlorine is Cl2, so it needs electron, and we have 2 of that. Or let's not write the number of electrons, let's just say it's just gain electron. We don't know how many, okay? So it gains electron and it makes Cl minus, right? Now we have to balance this reaction. We have 2 chlorine here, so this needs to be 2. And we have 2 chlorine, we have 2 negative charge, so there should be 2 negative charge on the reactant side too. So we need 2 electrons, okay, to balance it. To write the complete redox reaction, we should have the same number of electrons. So here we have 2 electrons, here we have 1 electron, so we need 2 electrons to make it a full redox reaction. We should have the same number of electron lost or gained. So we add 2 to the whole half reaction. So now we have 2 electron and 2 electron. If you add these two, so basically you write 2 Na. First I write all the reactants. So you write all the reactants. So plus Cl2 plus 2 electron gives you the product, and you write the all product. 2Na plus 2 electron plus 2 Cl, right? And then you can cancel out the 2 electrons on both sides of the reaction, and Na plus and Cl minus gives you NaCl, right? And you have 2 of each, so it gives you 2 NaCl. So that's a complete reaction. 2 sodium plus chlorine, Cl2 gives you 2 NaCl, and that's what we have over here. The same thing with here. So you have copper as solid, and you have Cl2 plus. So if I want to write the half reactions, so I have Cu gives you Cu2 plus 2 electron, because it needs to be charge balance. It's 2 positive, so it needs 2 electrons. And the other half reaction is Ag plus. It needs an electron to make Ag solid. And again, we have 2 electrons here. We need 2 electrons, so we add 2 to all of that, and then when we add these 2 reactions, we get what we have over here. So the number of electrons transferred, gained or lost, should match, okay? So if it's not the same number, you multiply a number to make it the same number of electrons. So that was the end of this video. In the next video, we're going to talk more about oxidation state, which is close to the charge for molecules like water, for example, for molecular compound, not ionic compound, because they don't have a charge, but we have to find the oxidation state.